Great. My name is Paul Jones. I am the current president of the Ancient City Astronomy Club in St. Augustine, Florida. And I'm also one of the founding members of that club. It goes back to January 1974. I was 3 years old when I joined. Well, actually 19 to be exact, but in those early days, one of the first groups that reached out and helped us in our fledgling group was the AstroGator Astronomy Club, which you guys formed out of when a lot of the members got too old to be in an AstroGator Astronomy Club anymore and became NEFAS. So thank you guys. I'm just kidding. Thank you all, and I thank Mike and Captain Kirk and Carl, wherever he is. Richard Sweetser, unfortunately, is no longer with us. He passed away, I think, in the 1980s. Fantastic observer, though. Was it 1994? Fantastic guy, amazing observer. So, okay, if you want to go ahead and get started, Greg. Let's see. I'm going to come out here a little bit. Everybody see? Not everybody meteor watches. It's probably one of the most challenging and toughest of the astronomical observing. There's many different types of observing in amateur astronomy, but I wanted to go into the downside of meteor observing. Everybody knows the weird, crazy hours, and what the heck is pre-dawn anyway? Whenever I put that in my meteor reports, everybody says, well, you better explain what you mean by pre-dawn, because nobody knows what that means. To me, it means the hours from 3:30 in the morning until sunrise. Pre-dawn. So the most bizarre hours that humans could possibly have is the best time for meteor observing. It's only best done in very dark skies and wide horizons. The less amount of light pollution, the better. Actually, meteor watching and deep sky observing kind of go hand in hand. What makes one good makes the other good. So there's a kind of an overlap between meteor observing and deep sky observing. It's a time-consuming event. No instant gratification on meteor watching. This is not walk up to an eyepiece, see the rings of Saturn, see a beautiful globular cluster. This takes at least an hour of observing, preferably 2, sometimes 3. So you got to have some patience. Putting ourselves up for the hot and the cold and the bugs and the humidity. We must be in Florida, right? The tricky one is, because you're looking for super dark skies, you kind of need lonely, remote, desolate spots like the swamp or the fairgrounds to get away from the light pollution and so forth. So that brings into consideration safety, security issues. Probably best done in a group, although I definitely am guilty of meteor watching alone a lot in crazy places in the middle of the night. And nothing's happened yet, knock on wood. Moonlight and weather, of course, are major disruptions that we all face and certainly interfere with meteor observing. Perhaps even more so than some of the other observing, because you can take a crack in a cloud and look at a planet or a deep sky object, but it doesn't help if you're trying to get good hourly count data on meteors. And then I was going to do a bumper sticker, sleep is overrated. Go ahead. Now the upside, I always like to go on a positive note. Meteor observing is an area of study that is wide open for amateur astronomers to make very valuable contributions in. The pros don't engage here very much. When they do, it's usually to analyze data that has been given to them by amateurs. Mathematical, usually, figuring orbits and so forth. So a lot of opportunity for amateurs to make very valuable contributions to science and become citizen scientists. The other thing about it, which is nice for me, I'm a KISS kind of guy, keep it simple, stupid. There's really no need for any kind of optical equipment or anything expensive or technical or complicated. This is the only thing you really need right here. Zero gravity lounge chair. Available at Walmart for $39.99. It's very, very comfortable to observe in. Staying awake when you get in them is the most challenging part. But you can do that basically with just that. And your eyes, of course. Something that I kind of was thinking about here recently and never really thought of before, but meteor observing is one of the best ways to begin to get a feeling for the speeds and the velocities that are throughout our universe. You know, stop and think about it a minute. We observe the sun, we observe the moon, we observe deep sky objects, we observe the planets. They're all basically motionless when we do it. We know in our minds that there are thousands of miles per hour and tens of thousands of miles per hour speeds involved in the universe and the objects in it, but it's not immediately apparent to us on Earth, except best in meteor observing, because these puppies are traveling 44 miles per second, and the quick flash lasts a tenth of a second in most cases. So just realizing that you're able to see the types of speeds and velocities that are about in the universe makes it very attractive to me. I put the one in red there in the middle. I think the absolute number one upside of meteor observing is that it gives you the opportunity to learn the night sky. Most folks are amazed at how well I know the constellations. Well, after 45 years of meteor observing, I better know them. It's just an offshoot, a byproduct of meteor watching. You'll know the constellations. You'll know this night sky, how it works. You'll know azimuth, elevation, right ascension, declination, zenith. All of those funky terms that tend to get overlooked a little bit, especially in this modern day of go-to telescopes and everything automatic, and you don't even have to even look up anymore hardly. It's still good to know those basics, and meteor observing will give you that chance. I love the unpredictability of meteor observing. If you go out with a telescope, you know Saturn's going to be there. You know the moon's going to be there. You know the deep sky objects will be there. But with meteor watching, you never know what the next second is going to bring. No two meteor events are alike. Interesting concept. Totally different than most observing in astronomy. The opportunity to just simply sit back and enjoy the beauty of Mother Nature going on at the cutting edge of reality with no optical aid at all. Just what's happening in our eyes.
There's a little bit.
Everybody hear me? What's that? Oh, yeah, except a little bit. Although I'll tell you though, I don't usually use my glasses. Depending on the type of vision issue you have, mine is I can't see close, but I can see far away, so the glasses actually hinder that. But that is an issue, you're right, for sure. And the chance, of course, for us to all become citizen scientists. Okay, Greg. Quick introduction to Meteors 101. Most of us know this. It's pretty basic stuff. They're not stars. They're tiny particles of space debris about the size of this grain of sand, speck of dust. Some are larger. We'll talk about that in a minute. They collide with the Earth's atmosphere at speeds up to 44 miles per second. Usually, most of them are between 22 and 44 miles per second when they hit the upper atmosphere, and they burn up from friction with the air in a process called incandescence. The three terms that are used in meteors, and they're juxtaposed, and they're quite used in the wrong situations by a lot of folks who don't know. Meteoroid, which refers to the particle in interplanetary space before it enters the Earth's atmosphere. The meteor itself is the flash of light that we see in the night sky. And meteorite, of course, is what's left over if they penetrate the entire surface, the entire atmosphere, and strike the ground as meteorites. A lot of times you'll see people talking about meteorites when they really mean meteors, and it confuses the heck out of folks who don't know. So again, one of our outreach things is to try to help folks separate all this correctly. And nowadays, most of them begin to burn about 75 miles above the Earth's atmosphere, and most, not all, completely burn up in a fine dust at a height of about 30 miles. Meteor is from the Greek term meteoros, meaning high in the air. For most of human history, people thought that meteors had nothing to do with interplanetary space at all, that they were atmospheric phenomenon, something akin to night lightning. So we carried that term over now. We call them meteors, which really is from the Greek word meaning having to do with the atmosphere or meteorology. Interesting there. They hit the atmosphere constantly, 24/7, 365, morning, noon, and night. 48.5 tons of metric material falls to Earth each day in the form of fine meteor dust. We probably dust that up in our houses sometimes without even knowing it. Two sources, comets and asteroids, produce virtually all meteors. At night, they say that the average number of meteors that you will see on a dark, clear night, if you've got good wide horizons and minimal light pollution, is about 7 per hour. That is a background rate, like a Geiger counter, counting radioactivity. That number jumps up or multiplies during meteor showers. And we'll talk more about in a minute. The two kinds of meteor showers, major and minor, right? Like baseball, the major leagues and the minor leagues. The major showers are classified as ones that produce 10 or more meteors per hour. And minor showers are ones that produce less than 10 meteors per hour. Simple way to keep them apart. Okay? Okay, Mr. Ray. Oh, did you already? Yeah. Boy, you're quick, man. Meteor showers 101. This is obviously and definitely the best and most interesting time to do meteor observing. You really have to be hardcore if you want to get out and do meteor observing away from major showers. I've been known to do that many times. But I can tell you it's much more fun and much more rewarding to do them during the major meteor showers. And of course, those are the ones that are associated with known comets, other than the Geminids, which they believe now is actually caused by a strange hybrid object that is a cross between a comet and an asteroid. Phaethon 3200, I think it's called, somewhat akin to these strange interplanetary interlopers that are coming into the solar system here lately. Let's see, this is what makes it cool. The meteor showers are visible from the Earth at the same time every year. You can almost set your clock by them. They vary a little bit in the actual peak of the activity, but the dates pretty much remain the same from year to year. August 12th is the Perseid, December 12th the Geminids, and so on and so on. Makes it really nice. And of course they increase or multiply the number of meteors seen in a given night. I put that in red down there, the next bullet. Meteor showers come from the same point in the sky called the radiant. This is a magical thing that happens, and it makes, to me, meteor watching worth everybody's while. We'll talk about it in a minute. I've got some diagrams to show it. It's where the parallel line, the meteoroids are striking the Earth's atmosphere basically in parallel lines. However, from our perspective on Earth, parallel lines seem to disappear to a point in the distance. Has anybody ever been out on a railroad track and seeing the parallel lines of the railroad track, and as you look out into the distance, they appear to disappear to a single point in the distance? Meteors the same. I'll show it in a sec. The shower is named for the constellation that the radiant, which basically means the point on the sky where the meteors appear to radiate from. They can be seen in any part of the sky going in any direction, but if they are true members of that meteor shower, they will all track back to a point in a particular constellation that separates them from all the rest. Fascinating. The International Astronomical Union has a website, I'll talk about it in a minute, that lists over 700 known meteor radiants. Of those 700, only 9 are considered major. The other 691 are minor or less. But it's interesting to think that there are that many potential ones out there, and there are new ones being discovered all the time. Okay, Greg. Here's the biggies, the Major League. Most of you may know these. The 1, 2, 3, 4, 5, 6, 7, 8, 9 meteor showers every year that recur, that are considered major. In other words, all of these can be guaranteed to produce more than 10 per hour at their peak or maximum time. There's the dates that they usually occur in. Because the meteor streams are wide, over several million miles in space, we don't just see them on one night. We see them anywhere up from 6 to 8 weeks to 12 weeks going on from night to night over that period of time. But the best time, of course, is the peak, or the maximum, when we actually cross the center of the orbit of the comet that produces the spectacular displays that we see on the maximum night. They're all good. I've seen all of them dozens of times. Perseids and Geminids are in red because they're number 1 and number 2, boy. They're the best. Absolutely the best. The Perseids, which we just had, some of you may have seen the reports I did on them.
You did real good on that.
It was a pretty good show this year.
Yeah, even with full moon.
Even with the full moon, Roger, you're right. Yep, and the moon is a hindrance, of course, and then you're always up depending on what phase the moon is in. But generally, if there is no moon, totally dark, clear, it's pretty easy to see about 120 Perseids an hour to a minute. The Geminids in December are perhaps even a little bit stronger than the Perseids. I was able to see them in 2017, the last time Mother Nature's cooperated to see that one. I was counting 140 an hour from the Kansas inlet. It was absolutely spectacular.
Well, what time does the radiant rise in Geminids?
The Geminids are a really cool meteor shower. They appear in December, which is near the winter solstice, and the night is the longest. 12 hours of darkness, from 6 in the morning till 6 in the evening, 6 in the morning. It is theoretically possible on a clear night and a new moon for the Geminids to observe continuously for 12 hours. I've always wanted to do that. I've never done it. I don't know if I can do it anymore. Maybe 40 years ago I could have. But you can observe them all night long. And the peak of the rates usually occurs between 1 and 3 in the morning. Before that, you see a few rising every hour, peaking up about 1 to 3 in the morning, and then dropping again before dawn. But it's very possible to get 1,000, 1,500 meteors in one night if you're counting.
We plan on doing it this year. At the fairgrounds or at the Kansas Inlet?
Unfortunately, Greg, this year the Geminids are at full moon.
Oh.
Yeah, I was just looking, everything coming up is at full moon.
Yep. The rest of this year is shut down, unfortunately.
The Ursid might be worthwhile, but then that's going to be really weather dependent.
Could be. I'll have to check on that. Yeah, the Ursids are a pretty cool little shower.
Card that's got the moon phases.
Yeah, 2019 is one of the worst possible years for meteor observing. Almost all of the meteor showers are severely moon problem.
The 25th is new moon, so 22nd peak.
Excellent. Let's all get out for the Ursids. It's a pretty interesting little meteor shower. It was a joke in the ACAC for many years. We tried to get out and never saw anything, and it was always like the worst meteor shower we ever saw was the Ursids. But lately I figured out through experience the mistake was ours. We were not observing at the right time of the night, nor in the right direction. Once I finally figured it out, the last time or two I've watched the Ursids, they're a pretty darn good little shower. 15 an hour, not bad. Coming out of basically the North Pole, the Polaris almost. It's really interesting. But those are the biggies. Yes, Roger?
I've never observed the quadrantids, but wanted to, and it seems like they have a very short window that they can peak really fast and then they disappear.
Absolutely. Along with the Ursids, the quads, as we call them, the quadrantids are named from an old constellation,
Right.
Quadrans Miralis, that used to be a sail of a ship, I think, or something like that.
It's like a section,
Yeah.
navigational tool.
It's now we know it as Booties, the herdsman.
Yeah.
And the meteors come from there in early January, and they have a very sharp peak. Like, you know, if you ain't in the right place on the Earth, even though you're in the same night, you won't get the best rate. But every once in a while, it works out so that North Florida or the East U.S. is right over the point, and I've seen up to almost 100 an hour from the quadrantids. But
You know, what's cool this year is on the 4th of January, we have an event, NEFAS has an event at Mosh. We're going to be on the roof of Mosh with anywhere from 300 to 500 people showing up that night.
will they be there at 3 o'clock in the morning, though, Chuck?
Probably not.
Probably not. That's
But
the
at least they'll be
trick.
there for part of the night.
Could possibly begin to catch some of the early ones as early as midnight when the radiant pops over the horizon.
Yeah.
But yeah, the quads are a really good one, but a lot of folks, and the other problem is it's coldest time of the year, you know, in northern hemisphere, folks are looking at north of us in the real cold, 30 or 40 below zero, you know. I'm not getting out for any meteor shower in 30 to 40 below
40
zero.
below zero, where are you at?
Major leagues, there are also some pretty good minor league players out there. I wanted to list a few of these other meteor showers, probably that most folks have never heard of, which are pretty doggone good in their own right. Eta Lyrids in May during the Eta Aquariids, awesome little meteor radiant, up to 5 an hour. Up to June Bootids in late June, 27 June, are one of those meteor showers that comes way up in activity and then goes way down in activity from year to year, depending on the position of the parent comet. Very interesting. They also, you mentioned Tunguska, Roger.
Yeah.
The Tunguska event, they believe that a meteor from the June Bootids may have created the Tunguska event.
Wow.
Alpha Capricornids, if you guys saw my meteor reports on Facebook, saw quite a few of those this year, just in August and July and August. Very nice little meteor shower, very bright, colorful meteors, and so forth and so on. A lot of other times to be able to get out besides the majors. If the majors are blocked out by a full moon, and a minor one happens 2 weeks from that, guess what? You got the minor shower at new moon and perfect to observe. There's always something neat going on in meteor showers. Okay, and then we talked about location. The reclining chase lounge or the zero gravity chair makes meteor observing a whole lot more comfortable. Highly recommend it. This is only $39.99 at Walmart. Very good buy. Very easy to take around, easy to set up. Great. Location we talked about, dark, swamp, fairgrounds, both great. Wear clothes to cover skin. Stay warm with insect repellent. You guys have probably seen this at your star parties. We see it all the time down there in St. Augustine. These are folks who have been members of the club. Okay, they've been around the block a time or two. Show up at a summer meteor, not even a meteor event, just a star party. Tank top, cut off shorts, flip-flops. Folks, don't do that for anything, any time of the year, because that is like attracting mosquitoes.
Man, Paul, why are you gonna call me out like that?
I mean, I don't enjoy it, but I wear double socks, long pants, a jacket, even if it's 80 degrees at night and humid, you know, but you cut down on the number of mosquito bites, and that's a good thing. That's all I'll say about that. Another unfortunate thing about meteor observing is that most of the good ones are seen midnight or after. I've got a slide to show you a little bit. How much time do I have, Chuck?
Another 45 minutes if you need it.
Really?
Well, actually
Awesome.
10.
Can I cut the difference, 25.
As long
No,
as
just-
everybody want, you talk all night as far as I'm concerned, it's what.
And is it okay? I mean, I can go on for days. Just start waving your hand or giving me a hook sign or something.
We have to be out by 10,
Have to be out by 10, okay.
which means 9. 20 minutes would be good.
Okay, thank you. Thank you. That gives me a benchmark. Okay, unfortunately, the dawn and the pre-dawn are best number of meteors. It is quite possible to see them at 7, 8, or 9 p.m. in the evening, too, as evidenced by the beauty we saw the other night. Just not as frequent. Avoid the moon, wipes out most meteors. Patience, practice, perseverance, concentration, and experience come to you and make you a better observer. Okay? Next. This explains the diurnal variation of meteors, why we see more midnight and after.
Paul,
Let's turn the
hold
volume.
that a little bit further away from your mouth.
Oh, am I getting like a kickback?
Yeah.
Okay, sorry about that. This is the day side of the Earth. This is the night side of the Earth. Noon, midnight. Between sunset, this is sunset and sunrise. Between sunset and midnight, we're looking out the back door of the Earth's revolving. We're seeing it. If you've ridden a car through a rainstorm, you know that the raindrops are hitting the windshield big time, but you look in the back window and almost none are hitting that back window of the car. Same thing here. See a few in the early evening. Slowly approaching midnight, they begin to pick up. And then from midnight till dawn, we're hitting the front window as we travel around the sun. And we're seeing about 3 times more meteors after midnight than before. Okay? This explains the radiant effect. This is the observer with his zero-G lounger somewhere around the swamp or the fairgrounds or something. The meteors from the meteor shower are actually coming in parallel lines like this into the Earth's atmosphere. However, we, the observers, see that because parallel lines converge to a point in the distance from perspective. This, not just meteors, this is everything. Parallel lines of any kind do this. And that's how the concept of a radiant and the effect of meteor showers occurs. Okay?
So, if you don't, Paul,
Yeah. Question? Yes,
if
David?
you don't mind, I don't know if you want me to hold questions till the end. That I've actually found interesting because I always thought that what I was seeing was them skipping off in different directions. But I guess they more or less just keep going straight as they come in.
Pretty
They don't
much.
alter the direction.
Pretty much, yep. They're
All
not
these years.
perfectly parallel to each other, but they're mostly parallel to each other. So the effect that is to have is that instead of a single infinitesimal point, like the period on the end of a sentence, the radiant is a very small area. So they can actually, if you're looking closely, you can say, wait a minute, that one didn't perfectly go the way the other one did, yet they can still be. And then there's that one that even though it's coming parallel at you, it comes directly at your eyeballs, David, and that is called a point meteor, which will be just a flash in the night sky, no apparent motion
Hopefully.
in it at all.
It will be the last meteor you
It's,
ever
That's all you'll ever see.
Yeah, it can get risky out there. It sure can. But most of them are going to be seen flying away from that point in the sky called a radiant, and the farther away you get from that radiant, the longer those tracks will appear to be. Got a couple pictures that show that. Go ahead. This just shows the effect of a rising radiant. As we all know, the world turns, and as it does, things rise. Radiants rise with the constellation, and as it gets higher in the sky, more meteors are seen from that radiant. Okay? Pretty cool shot here. I hope I'm not blocking you guys' view here. The Perseids that photographed at maximum in 2013, this is looking toward the radiant, which would be right around in this area, right up here. The double cluster is about the radiant position for the Perseids at maximum. And you can see that as you get farther away from that radiant, these streaks get longer and they get shorter near the radiant. And then theoretically, if you see one right on the radiant, that would be your point meteor, or just like a iridium flare. And nowadays, with all those flaring satellites, it's really hard to differentiate between a point meteor and a flaring satellite. I almost never call them anymore unless I'm darn sure that it was not an iridium flare.
That one that's parallel to the horizon there, you think that that's a Perseid, or could it be a sporadic?
Could very well be a sporadic. That's a good catch, Roger. I noticed that when I was looking closely at this slide. It doesn't exactly parallel the other ones, nor does this one. This one is probably a sporadic. Okay? And I think there's one or two others
There's
in
one on the
there.
left edge that really is
This one, yes. Yeah, good, Mike. Good catch. Yeah, this is obviously not a Perseid. It could very well be from one of the other 14 radiants that are going on during the Perseids, but it is not from Perseus itself.
I've heard that sporadics are really just meteor streams that have died out.
Exactly right, Roger. Exactly right. It's been said that there are probably no such thing as a true sporadic meteor.
Yeah.
They just belong to meteor showers so old and so antiquated that they have gotten to the point where they may only produce one meteor a night or one meteor a week, so they're virtually impossible to determine as a meteor shower. But interesting stuff. Okay, great, go ahead. That first picture was looking north or northeast toward the radiant. In this picture, they turned the camera around and faced south. Now we're facing south with the radiant behind our head to the northeast. Now we see the parallel effects here. Just about every meteor in this picture is a Perseid.
Yeah.
And the difference in perspective, just turn your head around and look in a different direction. Fascinating.
Did you take this picture?
Pardon?
Did you take this picture?
Was that your photograph?
I wish. Yeah, that's mine. Yeah. No, it's borrowed from the internet, but
Yeah.
this type of picture is really not that hard to get, really.
Yeah, but you're obviously using someone's using a wide angle lens, maybe.
Yeah, this is probably a 14 millimeter lens, maybe something almost wide angle, very wide angle.
Equatorial mount.
Could be, and it's probably stacked images now. The digital images are all
Because the
stacked.
guy standing still, the
Yeah,
equatorial mount would have picked him up.
Yeah.
yep. Something makes me want to say it might have been California or something, because it looks like they're looking over.
And it's not that deep a
It's a
wide angle
statue.
because it's not both.
Right.
You're not getting a bowl effect. of the
Exactly.
lens. That's probably a
Exactly.
50.
It might be. And the Perseids can rain like that at maximum on a clear night. I've seen 240 an hour
Wow.
from the Perseids years ago. Fascinating stuff. Okay. There's the culprits, or the ones we thank for producing meteor streams. This is actually Comet SwiftTuttle. Did anybody get a chance to see that back in the early 90s? I did not. I wish I had. Did you? Excellent. It would look like a pretty nice comet. And this is the parent body that produces the Perseids. Comes around every 133 years. I'm afraid we'll miss the next one, folks. Over 100 years from now. But all of the particles streaming behind the head of the comet are what's responsible for the Perseids meteor shower. Okay. Little bit of showing the extent of the orbit of the comet. Goes out 133 years. Or half of that, I'm sorry, 67 or 68 years out, turns around 67, 68 years coming back in, and produces the particles that actually stream all the way around that orbit. Tremendous length of time and space. And it shows how when they get to this point in the inner solar system, they interact with the Earth's atmosphere, and we see the Perseids every August. Okay. Another example from a little closer view. This is sun in the middle. This is where the Earth is in August, November, February, May. We're not encountering the stream any other time of the year except in August, and that's when the Perseids are thickest leaves. Okay?
Don't hit it again between, I'm sorry, I'm not going back a slide.
What's that, David? I'm sorry?
I was just gonna say, so I'm assuming that the reason we don't hit it again between November and February is because the orbit is not perfectly flat with ours. It's
Correct, correct. The thing that makes comets so different than the rest of the bodies of, most of the rest of the bodies of the solar system is that they can come in from any angle, from below, from above, from 45 degrees.
Oh, that's
from
literally what your next slide is.
60 degrees. And in the case of some meteor showers, like the Orionids in October and the 8 Aquariids in May, both produced by Halley's Comet, which comes around in the flat plane of the solar system, so we encounter it twice a year, every year. Totally cool. And this, of course, just shows that by chance, Perseus happens to be in the background. So the point of intersection is in Perseus. And at different times of the year, it's in Orion, Aquarius, so forth and so on, Lyra. Okay. Another awesome picture of the Perseids in 2015, again showing that radiant effect. You can easily see that they're all coming from a point about right here, roughly. Totally cool. Okay. This is a really neat slide. I found this online. This was taken by an astronaut from the ISS, looking down and seeing the meteor hit the Earth's atmosphere below him or her.
Can you spell dumb luck?
Some people have a hard enough time seeing it from the Earth, and this one saw it from above the Earth.
Yeah,
Pretty cool.
60th of a second he took the picture
Do you,
with.
do you think
Absolutely amazing.
Do you think he's counting the days that he gets to go home?
Could be. Okay, Greg. I would like to meet and shake hands with the individual who took this picture. This is probably the most spectacular, one of the most spectacular fireball pictures I've ever seen. And remember, we were talking earlier about most of the particles that produce meteors are about the size of a speck of dust or a grain of sand. I'll guarantee you this baby was not that small. Okay, this one was a big chunk. How big? Maybe softball size? Roughly? Hard to say. What do you think, Roger?
I don't know, but when we were observing in the Osceola Forest, back when we had a site called the Sod Farm, we were observing the Perseus late one night. Remember this?
Yeah.
With Alan Kimball, and we had a bright Perseus that lit up the ground, and the trail on that thing. Alan took a picture of the trail, brown smoke trail. It
Yes.
stayed in the sky for like 15 minutes.
It will stay in the sky and it will hook and fork like a vapor
Yeah,
trail,
the winds will,
like a winding river.
yeah.
The Leonids that occur in November are very famous for that effect, especially in the years when they storm, which is every 33 years.
Neon twisters.
What's that here?
The Leonids,
The,
some of them will leave a neon
Yeah, they
okay.
spiral almost.
Really?
because
Yeah.
it's going so fast they
I've seen
ionize.
that.
Yeah. Did you guys get a chance to see the 1998 Leonid show?
Oh, yes.
Well, 2001.
2001 was pretty amazing, yeah, but 1998 was the fireball shower. When they were throwing out 20, 30, 40, 50 fireballs an hour.
Wow.
200 meteors and 40 of them being fireballs. It was just unbelievable.
You know what stunk about that? That was pre-digital photography.
True.
Because we had all the film cameras out for that one.
True.
Remember?
What's that?
That we had all the film cameras out for that one. Remember?
It was whatever year it
Yep.
was.
The Leonids are known for their 33-year cycle of storms. The last one was in 2002. It blows my mind to think that we're already halfway towards the next cycle,
Because we're getting old.
which will begin about 2032. It usually is about a 4-year cycle where the meteor shower is greatly enhanced. It was this past time, started in 98 and ended in 2002. If it does that again, could start as early as 2029. 10 years from now, folks, we could maybe start seeing the enhancement from the Leonids. I plan on being around. I'll try. It'll be worth it.
That's a storm.
Stay healthy.
That's not a shower. That's a storm.
Yes. Anybody fortunate enough to see a Leonid storm?
Yeah. Well,
Just several.
Several of you all did. Bless you. And I hope and pray that it does it again. Some of the professionals are saying, oh, well, the orbit's getting perturbed and it may not do it again. They said that before and they were wrong. So starting about 2029, 2030, let's start watching the Perseids with a the Leonids by a fine-tooth comb. And notice also the glow, they caught the glow. This baby was probably probably much brighter than a full moon and turning night into day. Just incredible.
Storm from the western United States.
oh yeah, that's
But probably did not reach the ground as meteorites.
To see
It
that.
might have been 99,
Okay.
because that was the 33 anniversary.
Just briefly, if you guys have seen the reports I do on Facebook, you're probably wondering what the heck all that stuff means. I can email this to you guys, this presentation, if you would like to have it. Just let me know. If I don't have your email, let me have it, and I will send this to you, and then you can fire away with questions. LM is limiting magnitude, how dark and clear the skies are. The times are recorded both local time, EST or EDT, and universal time, plus 5 hours in EST, plus 4 hours in daylight time. This is for comparing observations with other observers around the world. Absolutely the only reason. And we do latitude and longitude as a nailing down of where on the Earth we were to see it. Sky conditions expressed as a percentage of degradation, arbitrary. 25% of the hour was affected by clouds, 50% of the hour was affected by clouds, or 0 clear the whole hour. Boy, does that really ever happen. The direction facing is important. Because of that orientation, we saw the difference between looking northeast and the difference of looking south. Makes a huge difference in the types of meteors and how they're going to appear to you as an observer. And the data is recorded in 1 hour time increments for most meteor showers. At the peak of the Geminids and the Perseids, I take 15-minute counts. All of I send data to lots of different places, and they say, can you do 15-minute counts? 1 hour is not accurate enough. So I do 15-minute counts for the Perseids and the Geminids when I'm able to. Okay, Greg, next. Okay, if I take down, I've got a shorthand, meteor shorthand system. Put a steno pad on the clipboard to take down whether or not it's a Perseid or a sporadic or a delta Aquariid, whatever it is, how bright it was, what color it was, whether it left a train, and never take my eyes off the sky. It's taken a while to perfect that. Kind of like your drawing in a way, David. Not as talented, but it helps to catch more meteors. If you're writing down stuff all the time, taking away your eyes from the sky, you're going to miss stuff. Magnitude to the full magnitude, -4, +1, +3, so forth. Color, if any. Train, if any. Times are recorded only for a fireball. Back in the old days, we used to record the hour and minute of every meteor we saw, and we're missing half the meteors in the sky because we were looking at our watches. And it's crazy. I don't know why, but we did that. Any unusual characteristics of the meteor? Okay, go ahead, Ray. Who do I report the data to? First and foremost, the American Meteor Society. ALPO, which Dr. Mike is one of the executive directors of, I believe. Both of those I report to just one gentleman, Robert Lunsford, out in El Cajon, California, is the coordinator for both AMS and ALPO, so I knocked both of those out with one guy. It's really great. IMOs run out of Germany, International Meteor Organization. Dutch Meteor Society, they are one of the hardest workers in the field of amateur meteor observing. They do most of the real heavy work on analysis of meteor showers, so I always send my data to them. There's an E-Meteor News, E-Zine, published by a friend of mine, Paul Rogemans in Belgium. Excellent. All these sources are online. Of course, I report them to you guys, ACAC and NEFAS, and they're available to anybody who wants them for special studies. Okay? Couple of other miscellaneous stuff for meteors. I talked about the meteor doldrums, mid-January to late April. Meteor season goes from late April to mid-January. The season runs a whole lot longer than the doldrums. But when you go through those doldrums, it seems like forever. Zenithal hourly rates, Lord and mercy. This is pretty technical stuff. This is what the analyses of our data come to. The number of meteors that would have been seen if the radiant were at the zenith under perfect sky conditions. That's the way they make it unanimous from observers in Iran, observers in Belgium, observers in China, United States, Australia, putting them all together. Technical stuff, but very interesting. The anthelions, year-round zodiacal source of meteors. Very many of these fireballs we see could come from the anthelions. They are particles in the plane of the solar system that were left behind after the formation, like bits and pieces of houses are left around when you build a house. And they occur every night, every year, constantly. And a lot of those particles can produce the fireball, maybe even that one we saw Saturday night.
Wow.
And they're tracked. You can track those across the sky very easily, the positions. Earth grazers are totally cool, man. They're almost more spectacular than fireballs, and when they're both a fireball and an earth grazer together, it is just unbelievable. They cross the entire sky in a skipping motion because their angle of approach is so low, it's like skipping a rock across water. Bounces across the top of the atmosphere, burning and then getting out and stopping, burning and coming back in and burning again and stopping, like a etched line on a piece of paper.
Really famous daylight meteorite that was a meteor that was on. You can see it on YouTube, but it was right over. It was like over one of the national parks or something.
Yeah, I know exactly the one you mean, Roger. Many years ago, but everybody must have been filming that day. It was even long before digital photography and digital cameras. 70s, I think it was, early 70s. But everybody, I guess, were out and they got it, and it was absolutely spectacular. Broad daylight with that effect. Fireballs, of course, the holy grail of meteors. Technically, anything -4 or brighter. That's subject to observers, changes, and a whole other aspect of meteor observing. As we mentioned, the rest of 2019 is not good for the major showers. Full moon gets almost every one of them. 2020 is much better. Almost everything is favorable in 2020, so I'm looking forward to doing a lot more meteor work than cams. Oh my Lord. Cameras for all-sky meteor surveillance. This is a whole new cutting-edge technology that is coming out of JPL, Jet Propulsion Lab, in Pasadena in the Ames Research Center. They found a way to take regular, small security cameras, like the ones that guard our houses from break-ins, and adapting them to meteor work. It has revolutionized that. Dr. Mike is getting involved. There are several other folks in the Florida network of the CAMs.
Barbara Harris has one.
Who's that?
Barbara Harris.
Barbara Harris, yes. I have not met her, but I've heard of her.
She's a wonderful speaker too.
Yep. And they go all night. You can be asleep in your bed. Everything's being recorded. Then they send them every day back to the Jet Propulsion Lab that analyzes them, sends back complete data on each meteor, orbital period, radiant position, everything. It is incredible. And if you don't have the wherewithal to get out and visually observe meteors and the bugs and the heat and the humidity, excellent way to get involved in meteor work. You can set up a camera in your driveway. Okay?
Paul, do they point those things down at a convex mirror so that you get a very wide field? Is that from all the...
No, it's amazingly, Roger, it's the exact opposite of that. Back in the old days, that's the way they did all sky meteor work, was like on a fisheye lens that covered the whole sky, and the meteor track was about that small.
Yeah, exactly.
You buy a camera lens, it's almost as expensive as a camera. They're like, what are they, 7mm to 100?
Yeah. The ones they're...
right
Yeah,
there.
I've got
I've got a
a
little-
75
A
for
little
mine. so-
planetary camera, you can screw off the top and it's 150 degrees.
Yeah, some of the ones they use for cams will give about a 20 to 25 degree chunk of the sky.
Really, that's good.
And they're capable of observing meteors down to about the visual limit of a human, down to about 6 magnitude. Whereas the old ones, it would have had to about been a fireball to show up. So they've been getting much more accurate data on more meteors now than they ever used to. And a lot of the data that, if you go to the American Meteor Society website, my buddy Bob Lunsford puts out a weekly report that is based on CAMS data. So you're getting absolutely to the minute most accurate information about what's going on in the meteor world on a weekly basis. So check out these. I'll send this to y'all if you want to. You can look up these websites. Great resources, a lot of information. Okay, that's it. Questions?
Color of meteors.
Color of meteors. Okay, excellent question, Greg. Color in meteors are a little bit subjective. You can line 10 people up and you can see a bright meteor and 10 different people say, I saw pink, I saw green, I saw yellow, I saw orange, I saw blue. However, there is one common denominator, and this is on those really bright fireballs like we saw Saturday night. Most people see green in those super bright meteors. That's across the board. 10 people line up, 10 people say, yep, saw green in that one, when they're bright enough. They're finding out now that that is not anything to do with the meteor itself. It's the atmosphere
Oh, okay.
that's causing that. The effect of shooting that meteor through the atmosphere and all the ionization and all the heating and all of that stuff makes the atoms of the atmosphere lose an atom, and then they come back together and they let off a photon of green light.
Wow.
Pretty cool.
And your eyes are also hypersensitive to green. That's why green lasers look so hot and red ones are hard to see.
Yep.
So,
Yep. So a lot of folks now, on the ones that we call the earth grazers, where they go almost all the entire way across the sky, a lot of those are shifted to the orange spectrum. See a lot of orange in those. Shorter ones, yellow and blue, are the two colors that I see in most meteors. But again, some of that is subjective to the observer. But next time you see a bright fireball, keep in mind there's a good chance that you're going to see green in it. Pretty cool. Yes, Roger?
I used to be very much into satellite observing. I still love the iridiums, and I'll catch the ISS whenever I can. But there was and it could have been Dutch, but they were figuring out the orbits of these spy satellites, and they post the two-line elements on their website. And we'd have observing reports about the KH satellites when they come over and all this kind of stuff.
Oh, yeah.
But
Yeah. Nowadays, the websites like the Sky and whatnot will actually show you the satellite that is going over. Like ISS, we know that it's going around, spot the station.
but they also tracked burn up or satellite reentries. I was wondering if anyone in your group looks for satellite reentries. They're predictable, but they don't, it could be seen. They know what orbit it's coming down on, but they don't know where in the orbit it'll be.
No, we haven't really got into it that deeply. I know over the course of my 45 years, I've seen a lot of re-entering space debris. They're a little bit different than regular meteors. You can kind of tell, but it would be neat to be able to say, okay, in 20 minutes we're going to get the re-entry on a piece of space junk from Sputnik 3 or whatever.
I remember, what was it, Skylab when it came down over Australia?
Yeah.
They just knew that it was going to come down one of these orbits soon, like that.
And NORAD, North American Air Defense Command, tracks all of that stuff. So That's another interesting aspect of it, for sure.
By the way, when the Leonid storm was expected in '99, but evidently the comet trail had been diverted by Jupiter or something like that, and it didn't occur till 2001. But I had a friend of mine that worked with me at the sheriff's office, was a good artist. I mean, he could draw anything. So I bought a hard hat from the hardware store, and I had him draw Chicken Little on it with running, and it says the sky is falling. Leonids.
It definitely, you can get that effect during the Leonid storms, for sure. It did storm in 1999 though, Roger, just not over the United States.
Yeah.
The maximum was over the Middle East, around Iran, Egypt. My late wife and I were still in Sicily, and I tried desperately to see it from Sicily because I was right close to the point, and it was solid clouds almost the whole night long. It took me months to get over that. But then had a complete rejuvenation during 2001. Was able to see that one, and the next year, 2002, it did it again, 2 years in a row. Unreal. Well, thank you guys very much.
When I first started back late 60s, we were using what they call the IGY system.
Yeah.
The IGY system.
You had somebody did all the recording, and you just called out when you saw something. So you stayed looking, the observer stayed looking up, and one poor sucker did all the writing.
Yep.
Does anybody use that anymore? I'm just wondering.
Not that I know of.
Okay.
Reason being, it's very hard in any one place to get enough people out there to do that, you know, but
We always had a group. I mean,
You set the radio to WWV in the background.
Yeah.
WV,
Yeah,
yeah.
they
Record with a cassette recorder.
no,
And
no, no, they weren't worried about that close for meteors, but in terms of counting, because you touched on it a little bit about keeping your eyes up,
Yeah,
and the whole point of that was that you never had, the observers never had to look down.
right.
we had a Vita root counters, a little hand.
Yeah.
Yeah, right. click.
Yeah, done that too.
Clickers.
Yes.
I timed for 5 minutes, roughly about 5 o'clock in the morning in 2001, and the group saw 132 meteors.
Remember
In
that?
that 5-minute
That was
period.
awesome.
Yes. it
Yeah.
was
You were out there at
unreal.
the swamp with us.
Yeah, that was
Yep,
awesome.
that was once in a lifetime, but prayerfully, we'll have a second chance.
Extrapolated to 15.
Some people have had 3 chances. Dr. Mike was able to see the spectacular 1966 Leonid storm as a young child in Jacksonville Beach growing up.
He was 6 years old.
He thought all of the meteor showers things like that.
So, I mean, you know, if we can make it another 10 years, you know, we've got a second chance to see that. So stay tuned, more to come.
Seen it from somewhere else.